Yes, Ehsan Aslam, hello. Is this audible to you?
Yes, good afternoon, ma'am.
Good afternoon. So, Ehsan, we had started with electrostatics. In this unit, we had started, see, there are two chapters in this unit. One is electric charge and field, and other one is electric potential and capacitance. So, we had started with electric charge and field, and we have covered a lot of portion in it. So, what's important for you so as to cope up with today's class? Firstly, we had done basics of electric charge, means what is meant by electric charge. So electric charge is the very basic property of matter, or you can say intrinsic property of matter that gives rise to various phenomena. Various phenomena includes your electric forces, your electric fields. So we have separate topics for electric force, we have separate topics for electric field. What you have to remember is the SI unit of electric field is coulombs. And CGS unit of electric field, this is electrostatic coulomb. ESU, this is electrostatic coulomb or stat coulomb. So SI unit of electric charge and CGS unit of electric charge. Then in nature, as you are already aware of, there are two types of charges which exist. One is your positive charge and the other one is your negative charge. See, basic theory includes one more thing that you have to remember. The minimum charge that is possible on one electron or one proton. This value you have to remember because this will be utilized. Plus minus 1.6 into 10 to the power minus 19 coulombs. See, 1.6 into 10 to the power minus 19 coulombs. This is the charge that is present in a single electron. If you take two electrons with you, so you will be having 1.6 into 10 to the power minus 19 coulomb and 1.6 into 10 to the power minus 19 coulomb. So that makes it 3.2 into 10 to the power minus 19 coulomb. Similarly, if you take three charges, that will get tripled. So minimum number what is possible? The minimum amount that is possible is 1.6 into 10 to the power minus 19. And remember this electronic charge value. So if you are taking electron, means a negative charge, just add a negative sign. If you are taking proton, particles like protons or any positive charge, then just add a plus sign in front of it. The theory that is required in the first part of this lesson is, see, protons are held through nuclear forces in this nucleus, while electrons revolve around nucleus. So electrons revolve around the nucleus through electric forces or electrostatic forces, which I'm going to tell you. So nuclear forces are 100 times stronger than electric forces. So tell me one thing, if nuclear forces are stronger and electric forces are weaker, will nuclear force allow protons to move easily or electric force will allow electrons to move easily? Electrons, because nuclear forces are stronger, so they won't allow protons to move because these are held with strong nuclear forces, while electrons are comparatively weaker if you compare nuclear forces and electric forces. So electric force will allow electrons to move. So whenever a body loses electrons, because proton transfer is not possible, so only transfer of electron is possible. Whenever a body loses electrons, then we call that body as a positively charged body. And if the body receives electron, means gains electron, then we say the body becomes negatively charged body. So it's not that when we say a positively charged body has gained some positive charges, it's just the deficiency or lack of electrons that makes a body as positive. Protons never get transfer, only electrons do get transfer. So this transfer of electrons, this method by which electrons are released from a body and transferred into another body, this process is known as charging. We call this term as charging of electrons. So in this charging, redistribution and transfer of electrons has occurred. Now see, there are three basic methods of charging. Charging by friction, charging by conduction, and charging by induction. So I'll just brief you with this. You can later on see the links of the videos and slowly keep on your backlogs clear. See, charging by friction. Friction you already know. Friction is what? The frictional force that you have studied, which opposes the motion. So what happens if two bodies are rubbed together? If two bodies are rubbed together, then frictional force acts on this. So work done in opposing this frictional force, that helps in transfer of electrons. So if this is one body, this is another body. If both of these are rubbed against each other, if both of these bodies are rubbed past each other, then electrons transfer up. So this is the first method, charging by friction. In charging by conduction, this is a similar case, means transfer of electrons occur only between two bodies. Just the difference is that both the two bodies are not rubbed past each other. Both the bodies are just placed in direct contact with each other. If two bodies, a charged or a neutral body, these are placed in direct contact with each other, then transfer of electrons occur from one and gaining of electron occurs in other. This is known as charging by conduction. Then we have charge. Okay, in charging by conduction, remember one more thing. In charging by conduction, if both the bodies are identical, what can be meant by bodies are identical? See, if you have sphere, then we can say the radius of both the spheres are equal. So if both the spheres radii are equal, then we say both the bodies are identical. So if two bodies are identical, then the charge gets distributed equally. Means, example you can see on the screen. If you have a 4e electronic charge on a body present and but the other body is neutral, means having no charge. The similar case which is on the screen, 4e and 0. So you only tell me, if you have 4e with you and you have to distribute it equally to two bodies, how much each will receive? 2e. It will receive 2e. So if two bodies are there, each will receive 2e. So that will be the case. You will take the mean value. Mean value will give you the resultant electronic charge present. So this you have to remember if you have two equal bodies. Now see, charging by induction. In charging by induction, what happens? We have a conductor. Conductor is neutral. Okay, when we say a body is neutral, we mean that the number of positive charges is equal to the number of negative charges. If the number of positive charges is balancing the number of negative charges, then the body is neither positively charged nor negatively charged. If the body is rich in electron or negative charge, then we say the body is negatively charged, no. Or if the body lacks electron or is positively charged, then only we say the body is positively charged. But if both of them are equal, the number of protons and electrons, number of positive charges and negative charges, if both of them are equal, then what do we say? We say the body is neutral. So if I take a neutral body like this body is a neutral body. And I have brought a glass rod near this neutral body. And this glass rod has certain charge on itself. Let's say positive charges are there. If positive charges are present on this rod, it will obviously attract negative charges towards itself. Yes or no? So if this is the case where two bodies are there, then see, positive charge will be attracting the negative charges. So see, all the negative charges have been resided at this place and all the positive charges are left at one of the corners. So what happens? This is the induced charge. We call these charges which have been separated. We call these are induced charge, and the charge through which we have done this induction process, we call it as inducing charge. So what has happened? We have separated both of these charges. We have kept negative charges together and we have kept positive charges together. Had we taken negative charges on this rod, then positive charges would have accumulated in this side and negative charges would have accumulated on the opposite side. This is known as induction, which can be also called temporary electrification. Is this clear? All right. Then we discussed Coulomb's law. Okay. See, Coulomb's law, what is meant by Coulomb's law? Just a second. Yeah. So see, if you have two charges with you and two charges are kept at a certain separation, let's say small is r is the separation, then Coulomb's law says that whatever is the electric force between these two charges, there are 2 points to remember. The first point says that electric force is directly proportional to magnitude, product of magnitude of these two charges. For example, if there is Q1 charge and the other charge is Q2, so just multiply Q1 with Q2, you get the product of Q1 and Q2. So electric force will be first directly proportional to it. This is the electric force. Then electric force is inversely proportional to square of distance between these two charges. If the separation between these two charges is small r, so F will be inversely proportional to square of them. Means F will be inversely proportional to r square, 1 by r square. So if I combine both these two factors, I get my final equation as F is equal to K Q1 Q2 divided by r square. F is directly proportional to Q1 Q2 by r square. So if I remove the proportionality sign, I get this equal to sign with a constant. So this constant is the proportionality constant used in Coulomb's law, and the value of this proportionality constant, this is K, this K is equal to 1 over 4 pi epsilon naught. See, what is this epsilon naught? This is a new symbol for you. Epsilon, this E symbol, this is known as epsilon. It's a symbol. It means how a force is dependent on a particular medium. If I put a naught in this, means a 0 in the subscript, it makes it epsilon naught. So epsilon naught is the permittivity, absolute permittivity for air or vacuum. So this will tell you how the force is dependent on air. If I take another medium, let's say epsilon naught G or something else, epsilon naught for glass, or if the charges are placed in water, some other medium. So if I change this value, then obviously the force will get changed. So this absolute permittivity tells us how the force is dependent on the medium. If we change the medium, how will the force get changed? So the constant that you have to remember, K, this is 1 over 4 pi epsilon naught. 4 you already know, pi you know 3.14. Epsilon naught means absolute permittivity for air. This value is 8.85 into 10 to the power minus 12. This value. So if I substitute all the values, means 1 is there, 4 I know, 3.14 we are already aware of, into epsilon naught's value. The resultant that I get is 9 into 10 to the power 9 Newton meter square per Coulomb square. This is your dielectric constant. This is also known as dielectric constant. This will be, when we'll reach the second chapter, that will make it more clear. Now see, constant is this. So in this equation that you have, F is equal to K Q1 Q2 divided by R square. F is the electrostatic force. K is the constant, which is 9 into 10 to the power 9, or it can be written as 1 over 4 pi epsilon naught. Q1 is the first charge magnitude. So when you are considering the magnitude, you don't take the sign. If it is minus charge also, then you take the value of the charge only. You just consider the magnitude. Then you have another charge. This is the magnitude of the second charge. And R square is the separation between both these two charges. So electric force is inversely proportional to R square. Means the separation between the two charges. This is your Coulomb's law. Is this clear? Then we had seen electric field. We have covered electric field in the last class only. So see, just understand what is meant by electric field, and you'll be able to manage today's class. See, if you have two charges with you and they are separated by a distance, so there will be interaction between them, means they'll be generating force on each other. This means that electric force is a property of two charges. If you have two charges, then only electric force will be able to generate. If I give you a single charge, or if a single charge is present, then what happens? This single charge exerts a certain electrical field around itself. Or you can say, if a charge is present, it has a certain space around itself in which electrical activities can be experienced. Means if I have a positive charge with me, so it will be having certain space around itself. So if I bring up another positive charge at a certain distance, I'll be able to feel the repulsion, electrostatic force of repulsion, because positive both will repel each other. So at a certain point in the proximity of this charge, I'm able to feeling certain electrical phenomena. So this confined space around a charge where electrical properties can be experienced, that is known as electric field. So this charge, which was producing electric field, we call it as a source charge, and the charge who has entered this electrical space, this is known as the test charge, because we are just checking the electric field of this source charge. That's why we call this as a test charge. And this source charge is kept stationary. This source charge is not allowed to. So electric field is a property of a single charge. Even if you have a single charge, that will have its own electric field. If you have two charges, both of them will have their own electric field. If a single charge is kept, it will have its own electric field. Okay, now see, this is one relationship between electric field and charge. Electric field is F divided by Q. This symbol that I have written, limit Q tends to 0, this simply means, this relationship means that I am the whatever force is exerted by this small q charge, I'm limiting its value so small that source charge is not moving. What is meant by this is that if I bring the small q charge near the capital Q, so small q will also repel capital Q, no? So capital Q will push itself. If you look in here, if we don't keep it stationary, small q will also exert force on it and this will move. But we want this source charge to be a stationary charge. So what we have done, we have added this symbol, limit q tends to 0. This means that whatever is the force experienced by capital Q due to small q, due to which it could have moved itself away from its position, we have limited its value, means now it has become negligible. Since it has become negligible, now our source charge will remain stationary, it won't move, and it will exert its electric field, and hence we'll be able to perform our test using the test charge. So, in short, in general, you can use this relation directly. Electric field is electrostatic force divided by the charge. Means electric field is basically all the force experienced by this charge. How can you relate it? See, if you take a positive charge, if I take a positive charge with me, plus 1 coulomb, if I put the value of charge as plus 1 coulomb, will the electric force be equal to the electric field?
Yes.
Yes. So it means what? Electric field is the total force experienced by a unit positive charge. Unless and until I make this charge as a unit positive charge, then only electric force will be equal to electric field. If electric field is equal to electric force, this is valid only for a positive charge. If you put any other value apart from 1, this relation won't be valid, means E will never be equal to F. E will be somewhat different from F. So electric force can also be defined as, or electric field can also be defined as all the force experienced by a unit positive charge. That is what is meant by electric field. So see, what is the SI unit of force?
Ma'am, Coulomb.
Force. Try to recall your 11th standards part. Laws of motion you must have done.
Yes, but I don't remember them right.
Newton. Remember? Newton for force we use Newton. So see, for electric force it's Newton, and for charge it is Coulomb. So SI unit of electric field will become what? Newton divided by Coulomb, means Newton per Coulomb. All right. So see, we have one more SI unit of electric field as volt per meter. But this is not discussed in this chapter. We'll discuss it in the next chapter, how voltmeter is valid. But you can at least remember force SI unit is Newton. For charge it is Coulomb. So SI unit will become Newton per Coulomb. All right.
Yes, ma'am.
Okay. Now see, as I've told you that electric force is what? Electric force, see, this was the source charge. This is the test charge. If I apply Coulomb's law, what I have told you, if you apply Coulomb's law, K will be the constant. First charge is the source charge, means capital Q. Second charge, this is the test charge, means small q. So K capital Q small q divided by the separation square between them, means R square. And electric field is what? Electric field is F divided by Q. So for getting electric field, if you divide this whole term by small q, you will get the electric field. So see, electric force is K capital Q small q divided by R square. If I divide electric field force by charge, this whole term will get divided by charge. Charge will get cancelled. I'll only get KQ divided by R square. So only a single charge is present in case of electric fields formula. Otherwise, you have two charges in case of electric forces. Similarly, you can put the values of electric field as constant as 1 over 4 pi epsilon naught, this term. 1 over 4 pi epsilon. Now you have to remember the directions, because in the directions will be used in today's class as well. See, if you have a positive charge, electric field is directed away from a positive charge. And if you have a negative charge, electric field is directed towards the negative charge. So if like this was your positive charge, so electric field is directed away from this. Means if I take a point over here, electric field will move away. If I take a point, electric field will be directed away. So wherever which points you are given, just take the point and move away from the charge. That will give you the direction of electric field. And similar is just the opposite case for negative charge. For a negative charge, electric fields are directed towards the charge in this manner. If you take a point over here, then this electric field direction will be near the charge. So for a positive charge, electric field is just away for it, like this. For a negative charge, electric field, these are towards the charge. That is how you take the direction of it. Is this clear, SR?
Yes, ma'am.
Okay, one more thing that you should remember is that this relationship between air and medium change. See, when we considered the medium for as air, when we had the medium as air, then the force was equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R square. If you change the medium will be having its certain dielectric value. So you just multiply it with K. So your force in a different medium will becomes Q1, Q2 will be there, 4 pi K times epsilon naught R square. This is the dielectric constant. It will be different for all the values. So if you have to ask anything, you can ask, and rest of you also, Fatima and Krishna also, if you want to ask, you can ask. So we'll just continue in 2 minutes. Let others join us also. Yes, all right. So see, electric field we had covered in the last class. This was where we left. We had seen graphs, how electric field is proportional to the distance, how electric field and electric force, all these quantities, these are proportional to the distance. So we had seen majorly three types of graphs: straight line, hyperbola, and parabola. Now see, we will begin with superposition principle today. Superposition principle. So this is not a very different principle. This is what you have studied already. It's just we will combine all these. See, if you have a single charge, that single charge will be having its certain electric field. If I give you two charges, both of these charges will produce their electric field. For example, if I give you this positive charge Q1 and I give you a point over here. So as I have told you in the last class, we have studied that electric field for a positive charge is directed away from the charge, and for the negative charge, electric field is directed towards the charge. So if I have this positive plus Q1 charge with me, at this point, I want to calculate the electric field produced by Q1. So what will I do? I will move away from this charge. This will be the direction of electric field because of plus Q1. Had it been negative, then it would have been in this direction, means towards the charge. Okay, so this was Q1. It has its own electric field. Now, if I give you another charge, let's say I have given you Q2 charge, some other charge is there. So at this point only, this was because of Q1. Let's say because of Q2, this will move away, means E2 will be the electric field because of Q2. Let us say I have given you n number of charges. If you have n number of charges present, all of the charges will be exerting their own electric fields. Q1 has its electric field as E1, Q2 has its electric field as E2. Let's say Qn. Qn means n number of charges, and let n be any number. It can be 2, 3, 4, 5, 6 till infinity. Let n be any number. So I have these many charges with me. So accordingly, if this is plus Q1 charge, then this will also has its electric field, which will be directed away, means in this. This will be the direction of electric field En. Right. So if you have various charges with you, there will be a number of electric fields. Superposition principle just says that if you have n number of n interacting charges there are, if you have n number of interacting charges present, then the resultant electric field, see there are various electric fields now, but I have to get the final electric field, whatever is the resultant electric field. So resultant electric field will be sum of individual electric fields added vectorically. Means if I have to take out the net electric field for this, so net electric field will be what? E1. I take the vector E1, I'll add vector E2 plus up till so on all the number of electric fields which are present. So if n number of electric fields are present, I will add it till En. So all the electric fields added vectorically will give me whatever is the net electric field. So see, instead of electric field, if I give you electric force also, then also superposition principle is valid. If instead of electric fields, if the charges had produced electric force, there were various electric forces in different direction. So a resultant electric field is given through this relation, means you have to take the individual electric fields and add them vectorically. You cannot add them algebraically the way you add electric charge. If 1 coulomb and 2 coulomb is there and I tell you what is the net charge, you will just simply add them and say 3 coulomb is the net charge. But in case of electric field is not a scalar quantity like electric charge. Electric field, electric forces, these have to be added using your vector additions. Vector additions include what? Vector additions include your parallelogram law and all the vector laws which you have studied. So I'll write down the definition also. So see, if I tell you if one electric field is in this direction, E1, and other electric field in this direction, E2. Both these electric field are present, making angle of 90 degree. So what you will do, you will properly apply all your laws which you have studied. Means net electric field, this is given by your parallelogram law. Parallelogram, according to parallelogram law, it will be E1 square plus E2 square plus 2 E1 E2 cos 90 degree. This will be the resultant, not E1 plus E2. E1 vector plus E1 E2, not simply E1 value plus E1 E2. All right, because you are not adding scalar quantities. So apply all your parallelograms. I'll discuss parallelogram law also once. All those who don't remember it. So see, for a system, having n number of n interacting charges, and interacting charges present, the net field, and this is not only valid for electric field, I am telling again, if you are given a system with numerous electric forces, then apply the same, take the directions of electric forces, take out the resultant through your vector addition. Then a net electric field at a point is the sum of, not the sum, vector sum. Sum will be algebraic sum. It is the vector sum of field due to individual charges. One more thing in this also, you have to remember the neutral point concept. For all those who don't know what is neutral point, I think I have discussed it. Neutral point. See, the point at which net force is zero or net electric field is zero, that point is called neutral point. So where many a times you are given a system where you have to choose a neutral point. So neutral point is basically, it's a point regarding electric field. We will say electric field is zero. So neutral point, it's a point at which net electric field is zero. Net electric field is zero means net electric field simply means individual electric fields get cancelled. Individual electric fields get cancelled. So I'm repeating once again. If you have various charges with you and all the charges will be exerting their electric fields, they will be producing their electric fields. So the net electric field will be given by, you will just add all the electric fields vectorically. Vectorically means you have to keep in mind their directions and you can use your vector addition to calculate the net resultant. All right. So just copy down. We'll revise parallelograms basic formula once and then we'll move forward and do some questions. Just write it done in the chat box. I'll know all of you have written. All right, I think most of you have written. If anybody is writing, just let me know. I'll stop. Okay, regarding your parallelogram law, you have already done this in your 11th standard in detail. So if you have two vectors, this is your vector A. It's just a basic revision. If you get through this question and you are required to use parallelogram law, so you should be able to use it. So if you have a vector A and you have a vector B, and both of these vectors represent the adjacent sides of parallelogram. How is a parallelogram? A parallelogram is in this manner. So if two vectors represent the two or adjacent sides of parallelogram, then the resultant is given by the diagonal of the parallelogram. Now, how the diagonal? Let's see if you complete the parallelogram. It will be in this manner. So the resultant of these vectors is given by the diagonal of the parallelogram. If A and B have angle theta with them, then the resultant force, this is equal to, take the magnitude of A, square it, plus take the magnitude of vector B, square it, plus multiply 2 with the product of A and B, and whatever is the angle between the two vectors, theta is the angle between A and B. Then use cos theta. This is the formula for how to calculate the resultant. This is how the resultant will be given. So if you have cos 90 means 0. So this part will become 0, only it will be under root a square plus b square. If you have cos 90 means if I give you electric field as E1, other electric field as E2, and I've told you that the angle between both of these electric fields is 90 degree, and calculate the resultant. If I ask you to calculate the resultant, so you can simply write E1 square as an a square, E2 becomes your B, this will be plus E2 square, E1 E2 cos 90 is 0, so this term becomes 0. Only what is left? Under root E1 square plus under root E2 square. This is your E resultant. This is how you use parallelogram law, and that is what is known as superposition principle also. There is nothing different in this. This was your basic revision of it. Okay, one question I am writing. So anybody wants to write these parallelogram law revision can note it down till the time I'm writing a question. Then we'll solve it. How to calculate the neutral point. All right, see, it says that two charges plus E and plus 4E are placed at a separation A. Means this is, let's say at point A plus E is kept. Let's say at point B plus 4E is kept. So both of these charges have been kept at 2 points, plus E and plus 4. And they are separated by what distance? They are separated by a separation A. A is the separation between A point and B point. So AB is what? AB is equal to small a. Now the question says, at what point on the line joining them, joining the charges, net field is zero? I have told you a point where net field is zero. What is this point known as?
Neutral point.
Neutral point. Yes, Krishna, neutral point. So basically it is asking us to calculate the neutral point. So it may happen in the examination that you can get the question directly on neutral point, that calculated neutral point. Now see, we don't know what is the neutral point. We are not aware of whatever is the neutral point of these, because we have not calculated, and we cannot take it in the middle of it because both of these charges are unequal. We are not sure about it. So let us take a random point. Let's say a point over here. This point I have taken it as a neutral point. I don't know what is the separation. I don't know what is the separation. I just know that I have taken a point and I'll calculate the net electric field as zero at this point, because this is my neutral point and it will be zero. Zero what? Electric field will be zero. Now see, let us take some random distances from it. All right, if this is this point, let us take the separation as x, because we don't know na, what is the separation from point A to this neutral point. Fatima, you tell me, if AB separation is small a, the point from the neutral point is x, what is this distance left?
AB minus x.
AB minus x, no, instead of AB you can take small a. Small a is given, so small a minus x. Correct, absolutely correct. A minus x becomes this separation from this neutral point. Now look at the question carefully. At this neutral point, the electric field due to plus E will be balancing the electric field due to 4E. That's why we are getting a neutral point. No, neutral point means what? Net electric field is zero. So if net electric field is zero, this means your electric field at point A, is balancing electric field at point B. Then only we are in a condition to call this as a neutral point. We are able to call it as a neutral point. All right, this is the separation that we have taken. Now we have to find out this only. What is this separation? So electric field at A. Yes, Hamza, you tell me. If the charge is plus E, the separation from the neutral point is x, what should be the electric field? Yes, Hamza, just write me. Your voice was cracking. Just write to me in the chat box. I'll help you if you're not able to understand. Just write me over here. I wasn't able to hear you. Okay, Hamza, see, for all of you, I'm repeating. Electric field. How do we write electric field? We use the constant K. What is this constant? This is 1 over 4 pi epsilon naught, or its value is 9 into 10 to the power 9, this constant. Then whatever is the charge, you write that charge. And whatever is the separation from the charge to that point, you write electric field as inversely proportional to that point. So this is the formula of electric field for a point charge, now that we have studied in the last class. So electric field is KQ divided by R square. Now we are considering at this neutral point electric field due to A. So Hamza, at least can you tell me, K will be the constant used. We are just writing electric field for A. What will be the charge for electric field at A?
Electric field at A plus.
Plus? Just look at point A. Which charge are you able to see at point A? E plus E. So E is the charge that you will take. E. Now Hamza, you only tell me. The neutral point is this. Okay, this N which you are able to see, this is the neutral point. Means net electric field is 0 at this point. This is the charge that we have. What is the separation between them?
X distance.
X distance. So in electric field, whenever we are writing, we write it as inversely proportional to square. So we won't just write X, we will write X square. Alright, so this becomes K small e X square. This is electric field produced due to A point, this small e charge. How? Electric charge is small e, separation between the point and the charge is X, and this is how we have put it in the equation that we have. Yes, Fatima Munir, you tell me. K will be the constant again used. What will be the charge at B? Yes, Fatima Munir. Or you can write me if you are unable to unmute. Rest of you also answer in the chat box. What will be the charge? Yes, Fatima. Fatima, only this? Yes, now it's correct. Fatima Munir, for you, the question is at point B, what is the charge? For writing electric field at B, I want to use the charge. So what is the charge that I have to put in? The way E was the charge at point A. What is the charge at point B? This is the question. Rest of you also answer, only Fatima has answered. Yes, Krishna has answered fully correct, Krishna. Apart from both of them, Fatima and Krishna, the other Fatima, yes, now Fatima, you are correct. It will be 4E. See, at point A, point B, which charge is present? 4E is present. So 4E will be the charge. So K we have written, Q we have written. Now we have to write R square. R square is what? R square is the separation of the point from the neutral point. Neutral point is capital N over here. The point is this B. So what is the separation? Akifa,
A
you tell
minus
me.
X square.
Okay, yes, Fatima, correct. It will be A minus X square. Yes, Ehsan, perfect. This is how we'll write. Ehsan, one more thing. It will be A minus X whole square, not only A minus X square. In this square will be on the whole radius. So that will make it A minus X whole square. So this will be A minus X whole square. So this means electric field at A has successfully balanced electric field at B, and we are writing this for the neutral point. Now physics is over. This is your simple mathematics which is required. K will get cancelled. E will be cancelled. What is left? 1 by X square is equal to 4 divided by A minus X whole square. Just take the root on both the side. Take the root. What you will get? If I put under root on both the sides, this will be 1 by X. This root will get cancelled. Under root 4, this is 2. And again, A minus X will be left. Whole square will get cancelled because of this root. Now I'll do simple cross multiplications. A minus X will be equal to 2X. A will be equal to 3X. So X will be equal to what? A divided by 3. So the part X, which we were not aware of initially, what was this separation of neutral point from plus E? Now we know it is X. If this is X, this means this is A by 3. This is 1 by third the value of the separation. If this is a by 3, this becomes a minus a by 3. So a minus, you will be writing it as a minus a by 3. So this part becomes 2a divided by 3. This is your separation. So if the question asks you to calculate neutral point from B, means plus 4e, what you will write? 2a by 4, 2a divided by 3. If you are asked to write the neutral point at from E, you will be writing a by 3. Now see, in this question, nothing has been specified, I think. It says at what point on the line net field will be 0. So whenever you are answering, you will write a by 3 distance from plus E, or 2 by a distance, 2a by 3 distance from plus 4e. Because if you will write only a by 3, that won't be correct, because this portion is not a by 3. This is not in the middle, no, that you will write a by 3, a by 3. So you have to specify from which charge is the distance a by 3, or from which charge is the distance 2a by 3. So this is how you use neutral point, where you have to calculate your answers. Regarding neutral point also, one more thing is easier. Whenever electric field is given to you, you can make it as a note and write this. If electric field is asked to you for a symmetrical system, then you don't even need to do any calculations like this. If electric field is asked to calculate for a symmetrical system, then remember that electric field at the center of symmetrical system, this is 0. Means you are not even required to calculate electric field. As in, if I have a plus q charge and a plus q charge, so with some certain separation between them, both of these charges are same, means this system is symmetrical. Plus q, this is a symmetrical system. Symmetrical means what? Right hand side is equal to the left hand side. So if at the center, means at the middle point, I have to calculate the electric field, don't even calculate even if the separation between them is a, or whatever is the separation between them, net electric field will simply be 0. You don't even need to calculate and check. Or likewise, if I increase number of lines, if I have a triangle, plus q, charges are there, then net electric field at the center of this triangle, this will be 0. Or if I just increase the lines, plus q for a square, if I take, then net electric field at the center of the square will be 0. Or I can increase the number of sides if I take a pentagon, a regular pentagon. Just the condition is that all the charges should be equal. This means a symmetrical system should exist. If it's not a symmetrical system, then you have to check. The way in the question we have studied, that wasn't a symmetrical system. One charge was plus E, other charge was plus 4E. So that was a different system, and that's why we were not getting electric field at the center. Had it been plus E and plus E, or a symmetrical system, then X would have come out to be A by 2, means exactly at the center, like in this case. So at the center also net electric field will be 0. Or if you increase the number of lines to infinity and lead to a circle, so whatever other charge is present on this circle, infinite charges also, net electric field at the center will be 0. Is this clear now?
Yes, ma'am.
All right. So just note down this, all those who have not written. Then we'll do one more question on the superposition principle. Just start writing this question and just try it yourself also. I'll discuss it once. At this, let's say this point is A, this is B, this is C, this is D. And at this point, you have the charge as plus 2q. At C, you have minus 2q. At D, you have minus q. And you are asked to calculate the net electric field at the center. So see, this is not a symmetrical system. You cannot take net electric field as 0 if, let's say, this point is O. So you have to calculate the electric field. Now see, separation, this is a square. So separation between all these is small. Just take 2 to 3 minutes, try to see where the electric field will be at this point due to all the charges. This is a hint. You can try in this manner. Take a point, like say plus A you have taken, A. So plus Q is there. At this point, due to this, where should be the electric field? Towards plus Q or away from plus Q. In this manner, you have to check. See all the electric field, take out the resultant using all your previous laws which you have done. Calculate electric field at point 2. Just take 2 to 3 minutes, and if anybody gets the answer, quickly send me in the chat box. All right, I think most of you have tried it yourself. Let's discuss it now. So see electric field at point O. So let's see what are the individual electric field present. So let us just consider a single point only, A point only. So because you will be given systems like this only. So A point. So we are considering only A point. At A point, electric field we have to calculate at A point. So see, electric field at A point will be produced due to which charge? Small q charge only. The direction of electric field because of plus q. This is a positive charge, and the electric field for a positive charge is directed away from the charge. So direction away from the charge will lead you towards this direction. This will be EA. This is electric field because of this charge, moving away from the charge. Similarly, for plus 2q, yes, Hafsa. Hafsa, you tell me. Because of plus 2q at point O, will electric field be directed along OD or along OB? Yes, Hafsa. Anybody else?
Along OD.
Correct. Yes, both of you are correct. Yes, Fatima. Fatima is also correct. It will be along OD. See, along OD will lead you to move away from this charge. If you will move along OB, that will lead you to move towards the charge. But we know for positive charge, we have to move away. So for plus 2q, this will be the direction, means EB. So EA and EB. For minus 2q, see, for minus 2q is a negative charge. So from O, you have to move towards the charge. So along OC, if you will move in this manner, this will be electric field due to C, means because of this point, minus 2q. Why? Because you're moving towards the charge. It is a negative charge. Similarly, for this negative charge, you have to move yourself towards this charge. This will be electric field at D. Any doubt still here? Is this clear to all of you?
Yes, ma'am.
All right. Now see, direction once you have found. All right. See, you have the direction now. You have to calculate what is the resultant electric field. But before that, you have to find out the separation between the point and the charge. Then only you will be able to apply electric field. No, that's what we have studied. If you have a charge and you're calculating electric field at a point, then you must know the separation, because in electric field is also inversely proportional to square of the separation. So see, we have to calculate this distance, this distance, this distance, and this distance. So for the calculation of that distance, we can apply Pythagoras theorem. If this is your triangle A, this triangle I'm talking about, yeah, this one. This is A, this is A. And we have to find out this side. So you will use simple Pythagoras theorem. According to Pythagoras theorem, this side means the diagonal AC. This is your triangle ABC. Your AC will be equal to what? Under root square or AB square plus BC square. AC will be equal to A square plus A square under root. AC will be equal to 2A square under root. So AC will be, if you take root 2 out, this will be, if you take 2A out, root 2 will be left. This is A root 2. So whole diagonal is A root 2. But do we need the whole diagonal? We just need the distance to this point, O only. So you will just half it. A root 2 divided by 2. So AO, which is equal to BO, which is equal to CO, which is equal to DO. All the separation of the charges from point O, that will be equal to A root 2 divided by 2, which you can also write A divided by root 2. So you can learn this value also, because many a time square is given with separation A. And if you are asked to calculate electric force, electric field, or any quantity, potential, whatever quantity you are asked to calculate at the center, so stop wasting your time in calculation of this distance. Remember that this distance will always be A by root 2, this distance, this part. Similarly, that rest of the distances will also be A by root 2. So we have the separation now. Now let us calculate EA, EB, EC, ED. Let us see what are all these. Regarding EA, electric field at EA. So look at the point O. You have to calculate EA. EA means constant used at electric field at A. Constant will be K. What is the charge?
Plus Q.
Plus Q. Yes, Fatima, it will be plus Q. So it will be KQ divided by R square. Now the separation between the center point which we are calculating and the charge. This is A by root 2 and whole square of it. Is it clear to all of you? How have we written this? K is the constant, Q is the charge, A by root 2 is the separation. So you will just square it. So EA will be equal to what? EA will be equal to KQ divided by A by root 2 whole square. So root 2 square will be 2, which will go up, 2KQ divided by A square. This is the value of EA that we have. Let us take the value of EB with us. Or let's do one thing. Which diagonals are in together? EC and EA are together, no? Let's say EC. Let's first check for EC. EC. So what are we calculating? This is a point O where two vectors are on one side, two vectors are on this arm. EA is here, EC is here, EB is here, and ED is here. We are solving first. What are we doing? I'm just telling what we are trying to do. We will solve this and get what is E1 means resultant of it. We will solve this and get resultant of it, E2. So you will be just having two vectors at the end, E1 and E2, with the angle between them, which you know. The angle between these two, you know, we'll see it later on. And you can just solve two vectors. This is what we have to do. This is the plan what we have to do. Regarding EC, now see, regarding EC. EC, K is the constant use. It's just that separation will be the same in all of them. Charge will be different. At EC, who is going to tell? Akifa, you tell me, what is the charge at EC for EC?
K
K is the constant, then charge
minus 2Q.
minus 2Q. So you take the magnitude of the charge only. So you will write 2Q only. Yes, Fatima. Don't write minus, just take the magnitude. Magnitude will be K 2Q divided by A by root 2 whole square. A by root 2 whole square will be same in all of them. K will be same in all of them. Now you just have to change the values of charge and see what are the electric fields you are getting. So 2, this will go up. Here it will be 4K divided by A square. So EA plus EC will be what? Because both of these vectors are together. These are parallel. So you can directly add EA and EC. If two vectors are parallel, making an angle of 0 degree, like in this case, then you can simply add the vectors. EA plus EC will be what? 2KQ by A square plus 4KQ by A square. That gives you 6KQ divided by A square. So we have solved this part. We have solved this one. this part, EAEC. So E2 that I was telling you, whatever will be the resultant of it, this is 6KQ divided by A square. Any doubt still here? Anybody wants me to repeat any part? Just let me know. Clear?
Yes, ma'am.
All right, fine, good. Now see, let us take it for ED and EB. Now this is very simple once you have solved the first term. So for EB, electric field at B, charge is what? This is plus 2Q. So rest of the things will be the same, only the charge will be different. So for EB, it will be K, charge will be 2Q, A by root 2 whole square. It will again be 4KQ divided by A square. Now what is left? Only ED is left. EC we have considered, only ED is left. The last part is left. ED. So ED, rest of the things will be same. K is the constant, that is same. Separation is A by root 2 only. Charge will be Q. Instead of taking 2Q, we will be taking only small q. It is minus Q, but we are considering the magnitude only. So the charge here, it will become Q. So it will be K Q divided by A by root 2 whole square. This will become again 2KQ divided by A square. Again, let us just take the resultant of them, means EB plus ED. This will give you, so this is coming out to be same, 4KQ divided by A square plus 2KQ divided by A square. This is now coming again 6KQ divided by A square. This is E1. E1 means this. ED we know, EB we know, we added them, we saw what was E1. So E1 is 6KQ divided by A square. So E1 we know, E2 we know. Now regarding these angles between them. So we have a common electric field E1, we have a common electric field E2. What is the diagonal making? Both these diagonals make an angle of 90 degree. This is a property of square. So you already know this angle. This angle between both of these vectors, this is 90 degree. I hope you all know this. The angles of the square at the corners is 90 degree, as well as the diagonals make perpendicular bisector of each other. That's why we are saying all these sides are A by root 2. These sides are equal and all of these angles, these are 90 degree. From your lower classes, you are already aware of this fact that the diagonals of the square make perpendicular bisector with each other. So E1 was 6KQ divided by A square. E2 is also 6KQ divided by A square. So let us do one thing. Instead of writing 6KQ by A square all the time, 6KQ by A square all the time, let us just write E. This is E, let us take it as E because magnitude is same. Now let us put the parallelogram law. You have two vectors, E1 is there, E2 is here, making an angle of 90 degree. So what will be the resultant electric field? This will be E square, means E1 square, plus E square, means E2 square. E1 square plus E2 square plus 2E1 E2 cos 90 degree under root. This is how you will write the net electric field. Cos 90 is what? What is the value of cos 90?
0.
0. So this whole term multiplied by 0 will give you 0. So net electric field is under root E1 square plus E2 square. If you substitute E1 and E2 as E only, E1, E2 as E, because the magnitude is same, it is coming 6KQ by A square. So you can write it as E square plus E square. This makes it 2E square, which is capital E will come out, only root 2 will be left. Now you can put the value of E. So net electric field will be what? Value of E is 6KQ by R square multiplied by root 2. This is your net electric field. Clear to all of you? Any doubts at any step?
No, ma'am.
Alright. So just repeat, just let me know if I have to repeat it. Otherwise, start noting it down. And wherever you get stuck, just ask me. You can write me in.
What is the value of E?
What is the value of
E.
electric field? Electric field is this only 6k by a square. No, electric field 1 because of one arm, the diagonal came out to be 6k by a square. Then electric field for the other diagonal came out to be 6k by a square. So instead of writing E1, E2, since the magnitude is same, I have written it as E, so that this calculation becomes easier. Otherwise, we had to put this 6k by a square in this under root only. So E is E1 and E2 only. So whose value was 6k by a square. All right.
Yes, teacher.
Okay, Hamza, any one of you? All of you have done?
Yes, teacher.
Let's move forward then. I hope nobody is writing down. Okay, so is this clear? This topic is clear. Superposition principle, how to use it, how to apply it.
Yes, ma'am.
So if you are given a different kind of system as well, with electric force is there instead of electric field, use in this manner only. If a triangle is given to you, here it was given a square. If a triangle is given to you, then similarly, take the point, look at the direction, get the electric fields or whatever forces are there. Once you have forces, once you have fields, once you have all your vectors, use your vector additions and check what is the angle. Many a times equilateral triangle is provided, so angle becomes 60 degree itself. So in this manner you have to check for various systems. Next topic for you, it is dipole moment. Before moving on to what is meant by dipole, let us see what is meant by monopole. Say a system, a confined system where only a single charge exists. Single kind of charge means if I talk about electron, only if I talk to you about a single electron. Is there any other charge present on electron apart from negative?
No, ma'am.
No.
No other charge is present. So this means this is a monopole. Mono means single, pole means polarity. So polarity can be positive, polarity can be negative. Mono means single, pole means polarity. Or if I give you example of a proton, a single electron or a single proton, not together. If both of these are kept separately, not together, then proton is only positively charged. No electron is present in a proton. So we say proton is a monopole. So monopole systems having only one type of charge. Only one kind of charge or only one type of charge.
Ma'am,
Of
can we
charge?
include neutrons?
Yes.
Can we include neutrino or neutrons in this?
Neutrons will be chargeless, so there won't be any point. You have to consider charge. If you take different particles or like positron or photons or different particles with
What about
plus E,
neutrino?
minus E, neutrino will be, it will be. You just have to consider the charges. Only remember the charge. Don't consider the mass, even if it is massless. Just remember about the charge. If it is minus E, if it is plus E, or for a proton it is plus E, the way we take for proton. So neutrino or particles like neutrons, especially neutrons. Regarding neutrons, these are chargeless. So neutrons will be under neutral particles. Monopole means polarity does exist. So you have to consider the polarity. If the particle has no charge present, then you will say the particle is neutral. It is chargeless. For monopole, either of the polarity should exist. Either
Okay.
of the polarity means either positive or negative. All right, Zed.
Yes.
So this is a monopole. So similarly, if we have a monopole, we will be having monopole moment also. Monopole moment always means net. Like if you have calculated in your 11th class also, moment means moment of torque and all these, where what did you do? You took the resultant of the forces. Monopole moment also means resultant of the forces. So monopole moment you are already in a habit of calculating. For example, if I give you, this is a system. Here it has plus 2 coulomb, it has let's say minus, or let's say plus 1 coulomb. So monopole moment will be what? It will be the net present. So monopole moment will be simply 3 coulombs. monopole moment will be 2 Coulomb plus 1 Coulomb, it will be 3 Coulomb. So this is how you calculate the net charge on a body. Till now you have been calculating in this manner also. So monopole means a single charge. Monopole moment means all the charges added up together. So all the charges added up together is what? The net charge on a body. That's what you have calculated, and that is what is meant by monopole. But this is not the case of dipole. When we are writing dipole, what is meant by dipole? Dipole doesn't mean that you just have two charges. Di means two, pole means polarity. So you have to have two kinds of polarity, but both the magnitudes should be same. Magnitudes should be same, as in if you have plus small q, other charge should be minus q. And the separation between these two is considered as 2a. 2a is taken by convention. 2a doesn't mean that it is we have to take the double of the charges. 2a simply means the separation between the two charges. Whatever, if it is given to you as 5 centimeter, so 2a for you, that will become 5 centimeter. So plus q, you have to have a positive charge, you have to have a negative charge. Plus q, minus q, and remember both of them should be q. Both of them should be q means both of them should have the same magnitude as well. Same magnitude, opposite signs makes a dipole. In case of monopole, you can have plus 2 Coulomb, you can have plus 1 Coulomb, you can have minus 1 Coulomb, because these are solitary. Both of these are not, any of these are not dependent on each other. Monopole means property of single charge. Monopoles means system which is having a kind of charge. Electron is a system. The polarity on it is negative. So electron becomes monopole with negative polarity. But the case of dipole, if you have an electron over here, means plus E is over here, then minus E if you take, then only it becomes a dipole. So electron and proton can make a dipole. Why? Because charge is same on one of them, 1.6 into 10 to the power minus 19 Coulomb. One is plus 1.6 into 10 to the power minus 19 Coulomb, other one is minus 1.6 into 10 to the power minus 19 Coulomb. That what makes your system a dipole. So a system having equal amount of positive and negative charges at a small separation. So I think in your chemistry also you must have done dipole. In chemistry also you must have seen, like if you have a molecule of HCl, so H plus Cl minus, exactly, with a certain separation between them, this is your dipole. This also forms your dipole. Or another example, let us take Na plus with some separation with Cl minus. NaCl also makes a dipole. So you can implement this in your chemistry as well. Both of this concept is same. You have to have a plus charge, you have to have a negative charge. Both of these charges should be separated, and the separation is taken as 2a. This is taken by convention. We are just following it. 2a has been said, so everybody uses it 2a. Don't get confused, never double the distance between them. 2a doesn't mean that you have to, if it is given 5 centimeter, you are writing it 2a as 10 centimeter. If 5 centimeter is the separation between these two charges, then 2a is 5 centimeter, not a, that you will double it. Only just take the two charges, whatever is the separation, the way you have been using it for Coulomb's law. For Coulomb's law, what do we do? We simply take the two charges, whatever is the separation between the two charges, we square it and divide it by the product of the charges. Similarly, for a dipole, for electric dipole, you have to have a single charge with you have to have two charges with opposite polarity, same magnitude, with a small separation between the two charges. This system or this setup is known as a dipole. Regarding dipole moment, See, dipole moment defines or gives the strength of the dipole. Strength of dipole means whatever values this is having. Means what is the strength of this dipole? The intensity of the dipole. Dipole, you know now, a minus charge with a plus charge with the same magnitude. So if you have this kind of setup, this is a charge. One end has positive charge, one end has negative charge. So what is the strength of this setup, means of this dipole? That is given through dipole moment. So there's a special way to calculate dipole moment. It is the product of take magnitude of any of the charge. See, both of the charges are same. One will, if I tell you one charge is plus 4 Coulomb, other will automatically be minus 4 Coulomb in order to make a dipole. So you can take 4 from this or 4 from here. If you are taking magnitude, both of them have the same magnitude. So take the product of magnitude of any of the charge, any of the charges, and this has to be multiplied with what? Product of charge and what? The separation that we considered. And the separation between them. And the separation between them means what? If this is your charge plus Q, this is your charge minus Q, separation between them is 2A. 2A is taken, 2L is taken sometimes. In some books, 2R is taken, in some books, 2A is taken. So we are just using it in general form. So product of magnitude of any of the charge. Dipole moment is denoted through letter P. This will be equal to C what? Any of the charge if I take, that is Q. And the separation between the charges is 2. This is the formula for dipole. And again, dipole is also not a scalar quantity like electric charge. So here also all your vector laws will be applied and direction will also be considered. Since it is a vector quantity, it will be having its direction. And what is the direction of dipole? See, in chemistry, if anybody remembers, dipole is from the positive to the negative. In chemistry, you must have done towards electronegative element. That is the direction of dipole. In, I think, chemical bonding or some lesson, it is given that it is directed towards the electronegative charge. In physics, it is opposite. In physics, the direction of dipole, it is from negative to the positive charge. From the negative to the positive charge gives you the direction of dipole. Also, if I tell you its SI unit, what is the SI unit of charge?
Coulomb.
And 2A?
Meter.
Meter, yes, right. Because 2A is the separation distance, and distance we have it as meter. So it will be Coulomb meter. This will be the SI unit. All right, basics is clear. Then we'll do questions. It will get clearer. Just note down these points as well. If time permits, we'll do a question also. Basic question, formula-based question. Also regarding monopole, whenever you are doing monopoles, so as I've told you, you have to remember only just consider all the systems which have the charge. Like electron has minus E charge, or positron has plus E charge, or take a proton or antiproton. Elements like neutrons, antineutrons, neutrino, antineutrino, all these are chargeless. and some of them like neutrino is massless also. So we cannot consider these charges when we are considering monopoles.
I'm done.
Yes, done.
Yes, sir.
So all those who have completed, you can leave now. We'll continue on the next class also. So just revise this basic concept. We'll discuss the questions.